Good morning, everybody. Sorry I couldn't be there today. Today, my daughter actually has a doctor's appointment, so I actually kind of forgot about it until I think Friday at some point, and then I was like, crap, I better schedule this. So I would have warned you ahead of time if I had remembered, but unfortunately I didn't. So here's a video. Let me know if you have any questions. You do not have to copy down this vocab, but I'm going to run it through for you and just make sure that you understand each of the components of a sphere. So we're moving on, okay, in volume. I took a picture here off the internet that I thought was a really good representation of what all these things are. Okay, so the first one is a radius. You guys are familiar with the radius. It's the distance from the center of a sphere to an endpoint on the sphere's surface. Okay, so any point in the center, take it out to the sphere's surface. Okay, that's the radius, right? And diameter, of course, is same thing, except for it's double that length because it goes all the way from one side to the other. Okay, so the vocab for diameter, distance from one point on the surface to another through the center of the sphere. Okay, the center is the point that is equally distant from all parts of the surface, so it's directly in the middle. It's not up here, it's not down there. Okay, and then the two that you really haven't seen so far, one's called a hemisphere. Now, a hemisphere is important. This is half a sphere. This might be the only one that I really want you to write down. You can pause the video if you want and write these other ones down, but they're not nearly as important as understanding what a hemisphere is, because we're going to work through some problems, and if it says hemisphere, you have to know what that is. So a hemisphere is half a sphere. Okay, so it'd be like the top portion of this one. You cut it off at the great circle, okay, and it'd be this top part. Which brings me to my next vocab word, which is great circle. A great circle is the largest circular cross-section of a sphere. It has the same circumference as the sphere itself. So this is a great circle. It's directly through the middle, okay? So it's like the same, it's not like, it is the same surface as the circumference. You can see the dotted because it's like in the back side, but it covers all the way across. So it's not a circle up here. It's directly across the center. Okay, it's like if you go to measure clothes at a tailor and you're getting a suit, right? And they gotta measure your shoulder length. Well, they don't go at the shortest part of the shoulder length. They go directly across the largest part. Well, that's what the great circle is. Okay, same idea. All right, so let's take a look at a couple examples here, and you do have an exit ticket at the bottom. All right, let me make sure. Okay, yeah. So what information would be helpful to finding the radius of a volleyball? Okay, well, if you want to find the radius of a volleyball, remember that's from the center out. Okay, we need to have some type of formula that has a radius in it. Well, if we know what the great circle is, okay, well, that would tell us the circumference. And the circumference of any circle is just 2 pi r. So you don't necessarily need the volume, right? You could just know the circumference, and that would help. But for the volume of a sphere, and I'm going to post another video as well that I found online that I thought was a good way of explaining why or where the volume formula comes from. But the volume of a sphere is 4/3 pi r cubed. Okay, remember that cubed is, it's kind of the similar idea, like it's a 3D circle, so it's got it cubed instead of squared, right? Pi r squared was the area of a circle, but we're now talking about a three-dimensional shape, so that's one reason why it's cubed. But like I said, I'll post another video if you want to watch, and it says like where that comes from. All right, so pretty quick video here. We're going to go through some practice problems like I mentioned. Well, it says 4 because I've copied it, but it's not number 4. But the first practice problem here says find the volume to the nearest whole number. So always pay attention to what it states that you're supposed to round it to. Just like on the quiz on Friday, I hope you guys paid attention to where it said rounding and that you completed that. That was that bonus quiz. But the volume of this sphere would be 4/3 pi, and then the radius here is 4 cubed. Okay, so the volume here would be 4/3 pi times 4 cubed is 64. Okay, divide that by 3 would be, what, 16, 21? Oh, it's not even. It's like 21.3, and then multiply that by 4. So let's just go ahead and use our calculator here. And it says round to the nearest whole number, so that tells you we should actually multiply by pi anyways. So 4 divided by 3, pi, and then let's see, 64. And that gives us about 268 inches cubed is our volume of this sphere. Okay. And I apologize if you heard some chewing in the background. That was my dog eating her breakfast. So she says hi. I'll send you a video if you'd like of that too as well. All right. Volume of this next one. Now notice that this is not a full sphere, right? This is a hemisphere. So this is going to be 1/2 the volume of a typical sphere. Okay, so this volume is 1/2 of 4/3 pi r, which r is 3 cubed. Okay, and again, just use your calculator for this. No reason to mess around and spend extra time on it. Okay, and that answer would be about 57, because remember we're rounding to the nearest whole number. Okay, as you can see there, 56.5 rounds to 57. So the volume of this hemisphere is 57 centimeters cubed. Okay, last one of this type. Again, volume. Now this one is a full sphere, so we don't have to worry about the half. And this is pi, and then the radius here would be 9, because this is the whole diameter would be 18. So it's 9 cubed. Okay, we plug that in our calculator. And let's see, I'm just going to remove this 1/2, 4/3 times 9 cubed. Would be 3,054 when you round it, because it's 53.6 feet cubed. Okay. So pretty simple on those ones. Just use the volume formula, 4/3 pi r cubed. Okay. Last thing that we're going to talk about today is called composite solids. So as you remember, I had you do that quizzes before regarding these. And composite solids just mean basically that you have 2 different or potentially 3 different composite shapes. So it means, like in this case, for instance, you have a hemisphere and then you have a cylinder, right? And in this one, you have another hemisphere and then you have a cone. And in this one, you have a cylinder, like the whole thing's a cylinder, but as you can see, this top portion is actually more like a cup. Okay, so it's missing that area. Well, that doesn't go straight down, so this is a hemisphere as well, right? So composite solids are basically shapes that are made up of more than one 3D shape. So you're going to basically have to do 2 different volumes here. You're going to have to do volume 1, right, which I'll just do is the cylinder. And as you recall, a cylinder is the area of the base times the height. Well, the base is a circle, so that would be pi r squared. So the area of a cylinder is pi r squared times the height. Okay, and then the second volume would be the hemisphere, which is 1/2, right, which of 4/3 pi r cubed, and 1/2 of 4/3 is 2/3. Okay, so we're just kind of simplifying these things here. All right, so we're going to find our 2 different volumes. And I'm actually going to shrink these down now that I have them set off to the side. Okay, so the volume of the cylinder would be, let's see, pi. The radius would be 10. And the height would be 18. And the volume of the hemisphere, the radius again is 10 cubed. Okay, so let's go ahead and type them into our calculator. So you have pi times 10 squared is 100. And then you have 18. So this would be about 5,000. What's it say to round to? Round your answer to the nearest whole number. Okay, so 5,655 because it rounds up, 5,655. And then the next one would be pi times 10 cubed. And this would be 2,094. Okay, so add those both together. 2,094 is the shape of the hemisphere, or the volume of the hemisphere, and then 5,655 gives you a total volume for this composite shape of 7,749 centimeters cubed. So composite shapes, they're not as bad as they look. They look kind of complicated, but all it is figure out what two shapes are being combined, okay, and then you can add up their totals and get the volume. All right, so let's go ahead and do the same thing for number 41 here. And again, pause the video if you need to copy that down, or if I'm moving too fast. Okay, next one. First volume we're going to talk about is the hemisphere, which is half of 4/3, which is 2/3 pi r cubed. So that's the top part here. Okay, then you have your cone, and a cone is 1/3 the area of the base times the height, and the base is a circle, so it's going to be one. Sorry, 1 second. The area of the base is a circle, and then times the height, so it's basically like a cylinder, only a third of that. As you guys remember, I poured that water into the cylinder. Kiara. Sorry, somebody's walking a dog close by. Darn them. Okay, so the volume up top for the hemisphere would be 2/3 pi times 6 cubed, and the volume of the cone would be pi times 6 squared times the height, which thankfully they're using the correct height. Remember, we don't want to use this height, we want to use the middle one, and it's already there for us, which would be 12. Okay, so again, use your calculator, type those both in. 2 divided by 3 times pi times 6 cubed. Okay, so the top one is going to be 452 feet, and the bottom one is 1 divided by 3 times pi, times pi times 36, because that's 6 squared, times 12. And ironically, it has the same exact one, so this is 452. Okay, and so those two combined would give you what? 904 feet cubed. Okay, so that's for the ice cream cone. Okay, last one here. Okay, last one is a cylinder. So a cylinder, as we said before, is pi r squared times the height, because it's a circular base, and then you multiply it by the height. Okay, and then we also have this hemisphere that goes on the top. But remember, we're going to subtract these two on this one, because it's not being added up above, right? It's not going up here, but instead it's taking away from that cylinder's volume. So instead, we're going to subtract the volume of this hemisphere, which would be 2/3 pi r cubed. All right, so pi r squared times height would be pi times 5 squared times the height of 9, and then the volume of the hemisphere, same radius. That's the nice thing about these composite shapes, is their radius is the same. So once you find one radius, it's pretty much just plug it in and plug it into your calculator and go. So in this one, pi times 25, because 5 squared is 25, times 9, gives you 706.8. So we're going to say 707 minus the volume of this hemisphere, which is 2/3 times pi times 5 cubed, which is 262. Okay, so 707 minus 262 is 445. And that is inches cubed, and that's the volume there. Okay, so just pay close attention to those composite shapes. And again, they look super complicated, but they're not. They're actually really easy. You just have to know the formulas for each of the shapes that combine into those. And we've done enough of them that you can either look up the formulas, or hopefully at this point they're kind of you're starting to get used to them. And for our project at the end of this unit, maybe we'll add some composite shapes as well for you guys to actually build. But just have a good mindset when you're going into it. Remember that if you find the radius for one shape, that's the radius for all of the shapes. Okay, or pay attention when they give you diameter instead of radius. So your exit ticket at the bottom, 4 questions. Finish those up. Let me know if you have any questions. Mrs. Obrist will be there for first period to help you out. Otherwise, just shoot me a Canvas message. All right, guys, have a great day, and I will see you tomorrow.